Okay. Once again, good afternoon, all of you. So in last lecture, we have discussed about the boundary layer concept, that is hydrodynamic boundary layer or velocity boundary layer. So we have discussed about the what is the layer in the laminar flow, then transition zone is there, then turbulent zone is there. So for that, we have discussed about the velocity boundary layer. Okay. After that, we have discussed about the thermal boundary layer. Okay. So in that, we have considering two cases. Case one as a T infinity is less than Ts, and second case as a T infinity is greater than Ts. So for that two cases, we have drawn the diagram for the thermal boundary layer. Okay. Then after that, we have discussed about the significance of velocity and thermal boundary layer. Then we have discussed about the for case liquid and gases, and for the case of oil and grease, what is the effect of the which effect is more, that is viscous effect is more or thermal effect is more. Okay. Then we have discussed about the graph according to the Prandtl number. If Prandtl number is 1, if Prandtl number is less than 1, if Prandtl number is greater than 1. So according to that, we have drawn the graph for that. Okay. After that, we have discussed about the what is meant by mean film temperature. What is the another name for the mean film temperature? That is the reference temperature. Okay. Then we have discussed about the characteristic length or equivalent diameter. Okay. So as we know that characteristic length or equivalent diameter is nothing but what is the equation for that? D is equal to 4 into AC divided by P. So by using that equation, we have to calculate the equivalent diameter. We have to calculate the equivalent diameter. So we have discussed the different geometries, that is for rectangular duct, then for rectangular annulus, then for annulus when there is a hole at the center, then center to center. Okay. So for that, we have calculated the value of equivalent diameter. Okay. So that part we have covered in the last lecture. Now today we have to discuss the next point, that is local and average heat transfer coefficient. So all of you give the new heading as a local and average heat transfer coefficient. All of you give the new heading as a local and average heat transfer coefficient. All of you give the new heading local and average heat transfer coefficient and draw this diagram. There is a one plate. Okay. So y direction is there, x direction is there, and fluid is flowing over that plate. At distance x, there is a heat transfer coefficient, that is Hx. Total length of the plate is L. Temperature of this plate is Ts, and temperature of the air or fluid which is flowing over that plate, that is nothing but Ta. Okay. So all of you draw this diagram. So from that we have to understand what is meant by local heat transfer coefficient and what is meant by average heat transfer coefficient. Okay. We have to consider one flat plate, and through that flat plate fluid is in motion over that plate having temperature is Ta, and flat plate having temperature, surface temperature is Ts. Okay. And length of the plate is capital L, and at distance x from the one end, the heat transfer coefficient is nothing but Hx. Okay. We have to draw this diagram. Simple diagram is there, plate is there, and fluid is moving over that plate. Temperature of the fluid, that is Ta, temperature of the plate, that is Ts, and total length of the plate is capital L. ओके. आता ही जी प्लेट आहे, प्लेटवरून आपण समजा फ्लुइड मोशन मध्ये असेल तर जो लेअर त्या प्लेटच्या कॉन्टॅक्ट मध्ये येणार आहे तर तिथं नो स्लिप कंडिशन असणार आहे, अँड बिकॉज ऑफ दॅट द हीट ट्रान्सफर इज टेक्स प्लेस ड्यू टू द कंडक्शन. ऍट द सरफेस ऑफ द प्लेट देर इज ए नो फ्लुइड इन मोशन. जो काही सरफेस असणार आहे तिथं फ्रिक्शन होणार आहे, अँड बिकॉज ऑफ दॅट फ्रिक्शन व्हॉट विल हॅपन, देर इज ए नो फ्लुइड मोशन, and heat transfer can occur only through the conduction. Okay. At the surface of the plate, if fluid is moving, but at the surface what will happen, there is a higher friction is there, and due to that high friction what will happen, fluid is in not in the motion, and because of that heat transfer is takes place due to the conduction. जर surface fluid motion मध्येच नसेल, स्टेशनरी असेल, तर हीट ट्रान्सफर कशामुळे होणार आहे, फिजिकल कॉन्टॅक्ट मध्ये होणार आहे. आणि फिजिकल कॉन्टॅक्ट म्हणजे कुठला मोड ऑफ हीट ट्रान्सफर आहे, तर कंडक्शन मोड ऑफ हीट ट्रान्सफर आहे. Okay. So all of you write down that statement. At the surface of the plate, at the surface of the plate, at the surface of the plate, there is no fluid in motion. At the surface of the plate, at the surface of the plate, there is no fluid in motion, there is no fluid in motion, there is no fluid in motion, no fluid in motion, and heat transfer and heat transfer can occur only through conduction at the surface of the plate, since there is a no fluid in motion, and heat transfer can occur only through conduction, only through conduction. ओके, म्हणजे जो काही ऍडजस्टंट सरफेस असणार आहे तिथे हिट कशामुळे फ्लो होणार आहे, बिकॉज ऑफ द कंडक्शन. आणि त्या लेअर पासून ते त्याच्या साईडचे जे लेअर असणार आहेत फ्लुइडचे, तिथं मात्र हिट कशामुळे ट्रान्सफर होणार आहे, बिकॉज ऑफ दी कन्व्हेक्शन. सो हीट ट्रान्सफर बाय कंडक्शन इज इक्वल टू दी convection. So therefore all of you write down, therefore heat transfer by conduction, therefore heat transfer by conduction is equal to convection, heat transfer by conduction is equal to convection, is equal to convection. Okay, so now we have to write down the equations of the conduction and convection, and that both equation we have to equate. Okay, so write down equation. Heat transfer by conduction is equal to, heat transfer by conduction is equal to, heat transfer by conduction, as we know that what is the equation for the conduction, that is q is equal to k into a into dt by dx. Now in this case there is a y direction, so therefore we have to write down the equation is a q is equal to k into a into dt by dy. Okay, so write down the equation. Heat transfer by conduction, heat transfer by conduction, heat transfer by conduction, heat transfer by conduction, q by a is equal to, q by a is equal to minus k into, q by a is equal to minus k into dt by dy at y is equal to 0. समजते बघा, वाय डायरेक्शनला काय असणार आहे, जिथे वाय इज इक्वल टू 0 आहे म्हणजे तो सरफेसला अटॅच असणार आहे, ती जी काही फ्लुइडचा लेअर असणार आहे तो सरफेसला टच असणार आहे, आणि तिथे ही ट्रान्सफर कशामुळे होणार आहे, कंडक्शनमुळे होणार आहे. बाकीचे जे लेअर असणार आहे तिथे ही ट्रान्सफर बिकॉज ऑफ दी कन्व्हेक्शन होणार आहे. सो dt by dy at y is equal to 0. Okay, so all of you write down heat transfer by conduction, q by a is equal to, q by a is equal to minus k into dt by dy at y is equal to 0, dt by dy at y is equal to 0. Okay, then write down the equation for the convection. Write down heat transfer by convection, heat transfer by convection. समजले, त्याच्यावरती जे लेयर असणार आहेत फ्लुइडचे ते मोशन मध्ये असणार आहेत, आणि मोशन मध्ये असतील तर कुठला हिट ट्रान्सफर असणार आहे, कन्व्हेक्शन असणार आहे. म्हणजे जेवढी प्लेट मधून हिट कंडक्ट होऊन त्या ऍडजस्टंट लेअरला येणार आहे तीच हिट कन्व्हेक्शनच्या रूपामध्ये फ्लुइड मध्ये येणार आहे. ओके, सो दॅट conduction heat is same as the convection heat. So now we have to write down the equation for the heat transfer by convection. Q by A is equal to, Q by A is equal to Hx into bracket Ts minus Ta, Hx into bracket Ts minus Ta, Hx into bracket Ts minus Ta. Okay, so as we know that heat transfer by conduction is equal to convection, so therefore we have to equate these two equations. So write down the equation. Q by A is equal to, Q by A is equal to Hx into bracket Ts minus Ta is equal to minus k into bracket dt by dy at y is equal to 0, and give the equation number 1. Give the name as a equation number 1. Equate that two equations. So therefore Q by A is equal to Hx into bracket Ts minus Ta is equal to minus k into dt by dy at y is equal to 0. Okay, then again we have to write down the equation. Q by A is equal to Hx into bracket Ts minus Ta is equal to 0.332 k by x Ts minus Ta into bracket Reynolds number raised to 1 by 2, Prandtl number raised to 1 by 3. So this is the standard equation. This is the standard equation for the rate of heat transfer, that is Q by A. Okay, so we have to directly write down this equation. We have to remember this equation. This is one of the standard equation to calculate the rate of heat transfer. So we have to directly write down the equation. Q by A is equal to Hx into bracket Ts minus Ta is equal to 0.33. म्हणजे सायंटिस्टने काहीतरी कोरिलेशन डिराईव्ह केलेले आहेत. आपल्याला समजा रेट ऑफ हिट ट्रान्सफर फाइंड आउट करायचं असेल तर त्या केसमध्ये तुम्ही हे इक्वेशन यूज करायचं असे हे स्टँडर्ड इक्वेशन डिराईव्ह केलेले आहेत. ते आपण स्टँडर्ड इक्वेशन डायरेक्ट लिहिलेलं आहे. त्याचं डेरिव्हेशनचा पार्ट आपल्याला नाही आहे. सो देअरफॉर वी हॅव रिटन दी डायरेक्टली इक्वेशन. ओके, सो ऑल ऑफ यू राइट डाउन Q by A is equal to Hx into bracket Ts minus Ta is equal to 0.332 K by X 0.332 K by X into bracket Ts minus Ta into bracket Reynolds number raised to 1/2. रेनॉल्ड्स नंबर कसा डिनोट केला जाते RE लोकल असेल तर X ऍट डिस्टन्स X म्हणजे जो काय आपण X डिस्टन्स घेतलेला आहे तिथला रेनॉल्ड्स नंबर म्हणजे काय असणार आहे REX ऍट डिस्टन्स X. सो REX raised to 1/2 and Prandtl number raised to 1/3. Okay, therefore write down the equation for the Hx heat transfer coefficient, that is local heat transfer coefficient at distance X. So write down that Hx is equal to Ts minus Ta cancel होणार आहे दोन्ही साइडचा. From that we get the equation for the Hx. So Hx is equal to 0.332 K by X REX raised to 1/2 Prandtl raised to 1/3, and this is the equation number 2. Okay, then local Nusselt number, as we know that what is the Nusselt number, what is the equation for the Nusselt number, that is Hx by K. So for the local Nusselt number we have to consider at distance X. So Nusselt number at distance X is equal to Hx into X divided by K. So from that we have to write down the equation 0.332 RE Reynolds number raised to 1/2 Prandtl number raised to 1/3. म्हणजे जे काही दोन नंबरचे इक्वेशन आहे इन दॅट Hx इज इक्वल टू 0.332 K बाय X आहे. तो X K बाय X जो आहे तो लेफ्ट हँड साइडला घेतलेला आहे. तो जर लेफ्ट हँड साइडला घेतला तर Hx इंटू X डिवायडेड बाय K म्हणजेच तो नसल नंबर असणार आहे. सो NUX इज इक्वल टू Hx इंटू X डिवायडेड बाय K. सो देअरफॉर वी गेट द इक्वेशन ॲज ए 0.332 रेनॉल्ड्स नंबर रेस टू 1/2 Prandtl number raised to 1/3. Prandtl number raised to 1/3. Okay, so Hx is nothing but local convective heat transfer coefficient. So all of you write down what is the meaning of Hx. Write down Hx is nothing but local convective heat transfer coefficient, and NUX is nothing but local value of Nusselt number at a distance X from the leading edge. Okay, so all of you write down this is the equation for the local convective heat transfer coefficient, that is Hx, that is equation number 2. Then we get the equation for the Nusselt number, that is 0.332 RE raised to 1/2 Prandtl number raised to 1/3. Okay, that Nusselt number is nothing but local value of Nusselt number at a distance X from the leading edge. Okay, so this is about the local heat transfer coefficient. म्हणजे ज्या पॉईंटचा आपल्याला हीट ट्रान्सफर कोएफिशियंट पॉईंट फाइंड आउट करायचा आहे तिथला जो काही हीट ट्रान्सफर आता डिस्टन्स X तर तिथला जो काही हीट ट्रान्सफर कोएफिशियंट असणार आहे तर त्याला काय म्हटलं जाते लोकल हीट ट्रान्सफर कोएफिशियंट. आणि थ्रू आउट प्लेट जर कन्सिडर केलं आणि त्याचा अवरेज हीट ट्रान्सफर कोएफिशियंट जर कॅल्क्युलेट केला तर त्याला काय म्हटलं जाते अवरेज हीट ट्रान्सफर कोएफिशियंट. सो ओके, देन राईट डाऊन द नेक्स्ट लाईन average heat transfer coefficient is given by, and average heat transfer coefficient is denoted by H dash. Okay, so write down average heat transfer coefficient is given by, average heat transfer coefficient, average heat transfer coefficient is given by, average heat transfer coefficient is given by, is given by H dash is equal to, H dash is equal to 0.664, H dash is equal to 0.664, 0.664 into bracket K by L, H dash is equal to 0.664 into bracket K by L, K by L, Reynolds number raised to 1 by 2, Reynolds number at distance L, Reynolds number at raised to 1 by 2, and Prandtl number raised to 1 by 3. So this is the equation for the average heat transfer coefficient. Whatever the plate we are considering, so for that whole plate, what is the average value of heat transfer coefficient? How to find out that average value of heat transfer coefficient? So for that we have to use this equation. This is the standard equation, 0.664 K by L R e raised to 1 by 2, Prandtl number raised to 1 by 3. Okay, so from these two equation, Hx equation and H dash equation, so we can say that H dash is equal to 2 into Hx. H dash is equal to 2 into Hx. H dash is equal to 2 into Hx. And Nusselt number, average Nusselt number, Nu dash म्हणजे काय असणार आहे? Average Nusselt number. So how to write the average Nusselt number? That is H dash into L divided by K. And what is the equation for that? 0.664 Reynolds number raised to 1 by 2 and Prandtl number raised to 1 by 3. Okay, समजले का बघा? लोकल हिट ट्रान्सफर कोएफिशियंट अँड अवरेज हिट ट्रान्सफर कोएफिशियंट ह्याची स्टँडर्ड इक्वेशन आहेत. एच एक्स म्हणजे काय असणार आहे? लोकल हिट ट्रान्सफर कोएफिशियंट. एच डॅश म्हणजे काय असणार आहे? अवरेज हिट ट्रान्सफर कोएफिशियंट. एन यू एक्स म्हणजे काय असणार आहे? लोकल व्हॅल्यू ऑफ नसल नंबर. आणि एन यू डॅश म्हणजे काय असणार आहे? अवरेज व्हॅल्यू ऑफ नसल नंबर. ओके, so therefore all of you write down Nusselt number Nu dash is equal average Nusselt number is equal to H dash L by K is equal to 0.664 Re raised to 1 by 2 Prandtl raised to 1 by 3. त्याच्या खाली नोट लिहा. Note, all the above results are valid for, all the above results are valid for if Prandtl number is greater than 0.5 or laminar flow is there. ओके, हे जे आपण इक्वेशन लिहिलेले आहे ते इक्वेशन कधी व्हॅलिड आहेत? ऑल अबो रिझल्ट्स आर व्हॅलिड फॉर दी Prandtl number is greater than 0.5 or if flow is laminar. At that time we have to use these relations. Okay, so this is for the these relations for the laminar flow. Now we have to consider the turbulent flow. Okay, then write down, all of you write down, for turbulent flow, for turbulent flow, write down for turbulent flow. So write down the equation for the local heat transfer coefficient, then average heat transfer coefficient, then Nusselt number, local Nusselt number, and average Nusselt number for the turbulent flow. So write down all these relations. All of you write down Hx, then H dash, then Nux and Nu dash. All of you write down the relation for the turbulent flow. That is local heat transfer coefficient, average heat transfer coefficient, local Nusselt number, and average Nusselt number. Okay, so all of you write down the equation for hx. Hx is equal to what? 0.0288 k by x re raised to 4 by 5 parental raised to 1 by 3. ज्यावेळेला लोकल घेतो त्यावेळेला आरई एक्स असणार आहे, ज्यावेळेला अवरेज घेतो त्यावेळेला आरई एल असणार आहे. अँड अवरेज ट्रान्सफर कोएफिशियंट दॅट इज एच डॅश इज इक्वल टू 0.036 k by l re raised to 4 by 5 parental raised to 1 by 3. re raised to 4 by 5 parental raised to 1 by 3. Okay, then write down the equation for the local Nusselt number, that is nux is equal to hx into x divided by k, hx into x divided by k is equal to 0.0288 re raised to 4 by 5 parental raised to 1 by 3, parental raised to 1 by 3. Okay, similarly average Nusselt number is equal to h dash into l divided by k, h dash into l divided by k is equal to 0.036 re raised to 4 by 5 Prandtl number raised to 1 by 3. Prandtl number is denoted by PR. Reynolds number is denoted by RE. Okay, REX is nothing but Reynolds number at distance x. REL is nothing but Reynolds number at distance L, that is local Reynolds number and average Reynolds number. In that form we have to write down the equations. Okay, so for the turbulent flow, these are the equations for the local heat transfer coefficient, average heat transfer coefficient, local Nusselt number and average Nusselt number. Okay, then next line write down for combination of laminar and turbulent flow. In some cases initially there is a laminar flow and after that there is a turbulent flow. So for that we have to use the another relations. Okay, so for the combination of laminar and turbulent flow, so all of you write down for combination of laminar and turbulent flow, for combination of laminar and turbulent flow, for combination of laminar and turbulent flow, laminar and turbulent flow. So write down average Nusselt number h dash is equal to k by l Prandtl raised to 1 by 3. H dash average heat transfer coefficient is equal to k by l Prandtl raised to 1 by 3, Prandtl raised to 1 by 3 into bracket 0.036 Reynolds number raised to 0.8, Reynolds number raised to 0.8 minus 836. Okay, minus 836. Then write down the value of average Nusselt number. So nu dash is equal to h dash into l divided by k, h dash into l divided by k is equal to Prandtl raised to 1 by 3, Prandtl raised to 1 by 3 into bracket 0.036 Prandtl raised to 1 by 3 into bracket 0.036 Reynolds number raised to 0.8 minus 836. Reynolds number raised to 0.8 minus 836. Okay. So for the combination of laminar and turbulent flow, this is the value of average heat transfer coefficient and average Nusselt number. Okay. Then we have to consider the two problems related to this. So all of you write down. Okay. So before writing the problem, yes sir, go to the directly next point. Then we have to solve these two problems. After the second problem, we have to go for the one derivation. Next. Okay, okay. So all of you write down the next point. After this point, we have to solve the problem because in the problem there is a need of this relation also. Okay. So all of you write down this point. Write down Reynolds analogy between Reynolds analogy between momentum and heat transfer. Reynolds analogy between Reynolds analogy between momentum and heat transfer. So now we have to check the analogy between the momentum and heat transfer. Analogy between the momentum and heat transfer. Okay, so that is Reynolds analogy. So give the new heading as a Reynolds analogy between momentum and heat transfer. Okay, so write down Reynolds analogy is the Reynolds analogy is the Reynolds analogy is the interrelationship between Reynolds analogy is the interrelationship between interrelationship between fluid friction and fluid friction and Newton's law of viscosity. Reynolds analogy is the interrelationship between fluid friction and fluid friction and Newton's law of viscosity. Newton's law of viscosity. So already we know these equations, that is Newton's law of viscosity, then what is the relation for the heat transfer. Okay, so all of you write down that equation, write down the first equation related to the Newton's law of viscosity, that is shear stress is directly proportional to the shear strain, that is tau is equal to mu into du by dy. Okay, so all of you write down that equation, write down tau 0 is equal to mu into dv by dy. Tau 0 is equal to tau 0 is equal to mu into dv by dy. That is the equation number 1. This is the Newton's law of viscosity. Shear stress is directly proportional to the rate of shear strain. Okay, so tau 0 is equal to mu into dv by dy. Okay, and then write down, this is the equation number 1. Then heat transfer along y direction, 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 heat transfer along y direction. So write down the equation for the heat transfer, that is q is equal to k into dt by dx. So here we are considering the y direction, so therefore q is equal to minus k into a into dt by dy, and that is the equation number 2. All of you write down heat transfer along y direction, we are considering the y direction, so therefore we have to take the dt by dy. Okay, so q is equal to minus k into a, q is equal to minus k into a dt by dy, q is equal to minus k into a dt by dy, and that is the equation number 2. Okay, And as we know that what is the equation for the Prandtl number? Prandtl number is nothing but mu Cp by K. So all of you write down the standard equation of the Prandtl number. Write down Prandtl number is equal to mu Cp by K. Prandtl number is equal to mu Cp by K. And suppose if Prandtl number is 1, so therefore 1 is equal to mu Cp by K. So from that we get the equation by for the K by mu is equal to Cp. So all of you write down Prandtl number is equal to mu Cp by K. So if Prandtl number is equal to 1, then 1 is equal to mu Cp by K. Therefore K by mu is equal to Cp. All of you write down, and from that we get the value of K. K is equal to mu into Cp. Prandtl number ज्या वेळेला 1 असणार आहे त्यावेळेला थर्मल कंडक्टिव्हिटी म्हणजे काय असणार आहे? विस्कॉसिटी इंटू Cp. K is equal to mu into Cp. So all of you write down K is equal to mu into Cp. K is equal to mu into Cp. Okay. So in equation number 2, now instead of K we have to put the value of mu into Cp. So therefore write down Q is equal to what? Instead of K we get the mu into Cp. So minus mu into Cp into A into dt by dy. Write down the equation for the Q. Q is equal to minus mu into Cp into A dt by dy. And in equation number 1, tau 0 is equal to, we have written the mu into dv by dy. So from that mu is equal to what? Tau 0 into dy by dv. So in that form we have to write down the equation. Q is equal to what? Q is equal to minus tau 0 into dy by dv into Cp into A into dt by dy. Okay. So from the equation number 1 we get the value of viscosity, that is mu. Mu is equal to tau 0 into dy by dv. So put that value into this equation. So therefore we get the value of Q. Q is equal to what? Q is equal to minus tau 0 dy by dv into Cp into A dt by dy. Okay, so dy will cancel. So what is the equation? Q is equal to what? Q is equal to minus tau 0 into Cp into dt by dv into A. Okay, dy cancel झालेला आहे. So what is the remaining equation? Q is equal to minus tau 0 into Cp into dt by dv into A. Okay, and as we know that जर प्लेट सरफेस जर असेल तर प्लेट सरफेसला व्हेलॉसिटी काय असणार आहे? V इज इक्वल टू 0. आणि टेम्परेचर काय असणार आहे? त्या सरफेसचं टेम्परेचर TS असणार आहे. ओके, सो राईट डाऊन ऍट प्लेट सरफेस V is equal to 0. At plate surface V is equal to 0 and T is equal to TS. At plate surface V is equal to 0 and T is equal to TS. And T is equal to TS. Okay, so this is the boundary condition for at the plate surface. Then we have to write down at outer edge of the boundary layer. At outer edge of the boundary layer, जो काय आउटर एज असणार आहे बाउंड्री लेअरचा, तिथे आपल्याला काय मिळणार आहे? व्हेलॉसिटी म्हणजे काय असणार आहे? फ्री स्ट्रीम व्हेलॉसिटी एवढीच असणार आहे. म्हणजे V इज इक्वल टू काय होणार? V होणार आहे. आणि टेम्परेचर कशावर होणार आहे? जे काय फ्लुइड मूव्ह होणार आहे त्याचं जे अगोदरची जी काय व्हेलॉसिटी असणार आहे, जे काय टेम्परेचर असणार आहे, ती सेम टेम्परेचर मिळणार आहे. म्हणजे एअरचं टेम्परेचर, दॅट इज TA. Okay, V is equal to V, then T is equal to TA. Okay, what is our equation for the Q? Q is equal to minus tau 0 Cp into A dt by dv. So take the integration. So dv from V is equal to 0 to V, and for the dt T is equal to TS to T is equal to TA. Okay, so that dv we have to take at the left hand side. So Q into integration of dv is equal to minus tau 0 Cp into A integration of dt, and that integration changes from T is equal to TS to T is equal to TA. Okay, so integration of dv is nothing but V, and V is nothing but V minus 0. So therefore Q into V is equal to minus tau 0 into Cp into A, and integration of dt is nothing but T, and limits for the integration, that is TA minus TS. So therefore instead of TA we have to put the TA minus TS. Okay, so we get the equation as a Q into V is equal to minus tau 0 into Cp into A into bracket TA minus TS. Okay, so we have to check the interchange the values in the bracket. So therefore negative sign will be cancelled. So Q into V is equal to what? Q into V is equal to tau 0 into Cp into A into bracket Ts minus Ta. Q into V is equal to tau 0 into Cp into A Ts minus Ta. Okay. Then we have to write down the equation. Q by A into bracket Ts minus Ta is equal to tau 0 into Cp divided by V. Okay, and as we know that Hx is nothing but tau 0 into Cp divided by V. So therefore, and Q is equal to what? Q is equal to H into A into Ts minus Ta. So but tau naught is equal to what? Cfx into half rho V square, and Cfx is nothing but local coefficient of drag or local skin friction coefficient. So Hx is equal to what? Hx is equal to Cf Cfx half rho V square into Cp by V. ओके, समजले का बघा. आपण सिम्प्लिफाय केल्यानंतर आपल्याला क्यू बाय ए टी एस मायनस टी इज इक्वल टू टाउ 0 सीपी बाय व्ही मिळालं. एच एक्स म्हणजेच काय असते? टाउ 0 इंटू सीपी बाय व्ही असते. आणि टाउ 0 म्हणजे काय असते? सीएफ एक्स इंटू हाफ इंटू रो व्ही स्क्वेअर. आणि हा सीएफ एक्स म्हणजे लोकल कोएफिशियंट ऑफ ड्रॅग किंवा लोकल स्किन फ्रिक्शन कोएफिशियंट म्हटलं जाते. त्याच्यावरून आपण एच एक्स इज इक्वल टू काय लिहू शकतोय? टाउ 0च्या जागेला हे इक्वेशन लिहायचं. सो एच एक्स इज इक्वल टू सीएफ एक्स इंटू हाफ रो व्ही स्क्वेअर इंटू सीपी बाय व्ही. ओके, सो व्ही स्क्वेअर आणि व्ही एक कॅन्सल होईल. सो व्हॉट इज द रिमेनिंग इक्वेशन? सीएफ एक्स बाय 2 रो इंटू सीपी इंटू व्ही. Okay, so hx is equal to what? Hx is equal to cfx by 2 into rho cpv. हा रो cpv लेफ्ट हँड साइडला घेतला तर तो डिनॉमिनेटरला जाणार आहे. म्हणजे hx बाय रो इंटू cp इंटू v इज इक्वल टू cfx बाय 2. समजते का बघा? रो इंटू सीपी इंटू व्ही हा लेफ्ट हँड साइडला घेतलेला आहे. एच एक्स डिवायडेड बाय रो इंटू सीपी इंटू व्ही इज इक्वल टू cfx बाय 2. आणि हा एच एक्स बाय रो इंटू सीपी इंटू व्ही म्हणजेच काय असते? तर स्टॅन्टर्ड नंबर असतो या. ओके, सो एच एक्स बाय रो इंटू सीपी इंटू व्ही इज नथिंग बट स्टॅन्टर्ड नंबर and it is denoted by stx. Okay, so all of you write down hx by cp into rho into v is nothing but Stanton number. It is denoted by stx. So therefore Stanton number is equal to cfx by 2. cfx by 2. आणि हेच कसं लिहू शकतो? इन द फॉर्म ऑफ इक्वेशन दॅट इज नसल नंबर डिवायडेड बाय रेनॉल्ड्स नंबर इंटू प्रॅन्टल नंबर. जर हे इक्वेशन तुम्ही सिम्प्लिफाय केलं तर हा जो काही सीएफएक्स असणार आहे, सीएफएक्स जी काही व्हॅल्यू आहे त्याच्यावरून जे काही आपल्याला इक्वेशन मिळते डिवायडेड बाय 2 केलं तर ह्याचं जे इक्वेशन असणार आहे ते काय असणार आहे? नसल नंबर डिवायडेड बाय रेनॉल्ड्स नंबर इंटू प्रॅन्टल नंबर, अँड दिस इज कॉल्ड ॲज रेनॉल्ड्स एनॉलॉजी. ओके, म्हणजे ह्याच्यावरून आपण काय करू शकतोय? जो काही शेअर स्टेटचा डाटा आहे, जो काही हीट ट्रान्सफरचा डाटा आहे, त्याच्या इंटर रिलेशनशिप वरून आपण काय करू शकतोय? हीट ट्रान्सफर डेटा फाइंड आउट करू शकतोय. ओके, so Stanton number is equal to cfx by 2 is equal to Nusselt number divided by Reynolds number into Prandtl number. This is called Reynolds analogy. 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 And write on the next line, by using this interrelationship, by using this interrelationship, we can infer, by using this interrelationship, we can infer heat transfer data. We can infer heat transfer data, heat transfer data from shear stress measurement. Heat transfer data from shear stress measurement. Okay, and now we have to go at the upside, yes sir, and take that first problem. Write down that first problem. All of you write down this problem. Write down that first problem. All of you write down the first problem from the screen. All of you write down first problem. Write down that first problem. Okay, all of you write down that problem. Air flows over a heated plate. Air flows. Air flows over a heated plate at a velocity of 50 meter per second. Air flows over a heated plate at a velocity of 50 meter per second. Full stop. The local skin friction coefficient at a point on a plate. The local skin friction coefficient at a point on a plate. The local skin friction coefficient. The local skin friction coefficient at a point on a plate is 0.004 full stop. Estimate the local heat transfer coefficient. Estimate the local heat transfer coefficient. Estimate the local heat transfer coefficient at this point. Estimate the local heat transfer coefficient at this point. At this point. Full stop. The following property data for air are given. The following property data. The following property data for air are given. For air are given. Are given. So write down the given data. Rho is equal to density. Density is given. Density is equal to 0.88 kg per meter cube. Density is equal to 0.88 kg per meter cube. Then mu is equal to 2.286. Mu is equal to 2.286 into 10 raised to minus 5 kg per meter into second. Kg per meter into second. Cp is equal to 1.001 kilojoule per kg Kelvin. Cp is equal to 1.001 kilojoule per kg Kelvin. Kilojoule per kg Kelvin. K is equal to 0.035. K is equal to 0.035 watt per meter Kelvin. Watt per meter Kelvin. Watt per meter Kelvin. Use the relation. Use Stanton number into Prandtl raised to 1 by 3 is equal to CFX by 2. Use Stanton number into Prandtl raised to 1 by 3 is equal to CFX by 2. Okay. And write down the given things from that statement. Velocity is given 50 meter per second and CFX is given 0.004. Okay. So all of you write down CFX is equal to 0.004. CFX is equal to 0.004 and V is equal to 50 meter per second. V is equal to 50 meter per second. And they have said that we have to use that relation only. Okay. In the problem itself, they have given the relation. So we have to use that relation only. So Stanton number into Prandtl raised to 1 by 3 is equal to CFX by 2. And how to calculate the Prandtl number? As we know that Prandtl number is nothing but mu Cp by K. So mu is given, Cp is given, K is given. So from that we get the value of Prandtl number. And we know the equation for the Stanton number. Stanton number is equal to Hx by rho v Cp. Okay. So but they don't given the value of Hx. Our aim is to calculate the value of Hx. So Hx is unknown to us. Rho is given, V is given, Cp is given. So from that, Stanton number is equal to Hx by 440 44044. Then we have to use the relation, and in that relation we have to put this value and find out the value of Hx. Simple problem आहे. Prandtl number आपल्याला डायरेक्ट मिळतोय. Prandtl number is equal to mu into Cp divided by Q. mu दिलेला आहे, Cp दिलेला आहे, K दिलेला आहे. त्याच्यावरून आपल्याला Prandtl number किती मिळालेला आहे? 0.65. आणि त्याच्यानंतर स्टँटन नंबर काय असते? स्टँटन नंबर इज इक्वल टू Hx बाय रो इंटू व्ही इंटू Cp. Hx आपल्याला काढायचा आहे, तो अननोन आहे. सो स्टँटन नंबर वी गेट ॲज ए Hx बाय 44044. Okay, and then we have to use the relation. They have given the relation as a Stanton number raised into Prandtl number raised to 1 by 3 into Cfx by 2. So in that equation we have to put the value of Stanton number, put the value of Prandtl number, and find out the value of Hx. Okay, so all of you do the calculation by yourself. From that we get the value of Hx as a 116.9 watt per meter square per Kelvin. Watt per meter square Kelvin. Okay, so all of you write down this thing. First of all, we have to calculate the Prandtl number, then we have to calculate the Stanton number, then we have to use that relation, and by the using that relation we have to find out the value of Hx, that is local heat transfer coefficient. What is the value of that? That is 116.9 watt per meter square Kelvin. Okay, so we get the value of Hx as a 116.9 watt per meter square Kelvin. Okay, so this is the first problem. Those who are remaining, they have to do the calculation afterwards and then write down the correct answer. Okay, so all of you write down the correct answer from the screen and do the calculation afterwards. Okay, write down the second problem. Write down the second problem. The crankcase of an IC engine, the crankcase of an IC engine, the crankcase of an IC engine measuring, IC engine measuring the crankcase of an IC engine measuring 80 centimeter into 20 centimeter, 80 centimeter into 20 centimeter, 80 centimeter into 20 centimeter may be idealized as a flat plate, may be idealized as a flat plate, may be idealized as a flat plate. The engine runs at 90 kilometer per hour. The engine runs at 90 kilometer per hour, 90 kilometer per hour, and the crankcase is cooled, and the crankcase is cooled, and the crankcase is cooled by the air flowing, crankcase is cooled, crankcase is cooled by the air flowing, by the air flowing past it, by the air flowing past it at the same speed, it at the same speed, same speed, same speed, full stop. Calculate the heat loss from the, calculate the heat loss from the crank surface, calculate the heat loss from the crank surface. Calculate the heat loss from the crank surface maintained at 85 degrees Celsius. Maintained at 85 degrees Celsius. 85 degrees Celsius to the ambient air at 15 degrees Celsius. 15 degrees Celsius due to road induced vibration. Due to road induced vibration. Due to road induced vibration, the boundary layer becomes turbulent. Due to induced vibration, the boundary layer becomes turbulent from the leading edge itself. From the leading edge itself. From the leading edge itself. Okay. So all of you write down the first given 80 into 20 म्हणजे लेंथ इंटू विड्थ दिलेली आहे. L is equal to, all of you write down, L is equal to 80 centimeter. So we have to convert that 80 into meter. So 0.8 meter. Then width is given 20 centimeter. So B is equal to 20 centimeter. So 20 centimeter is nothing but 0.2 meter. Then velocity is given 90 kilometer per hour. So we have to convert into meter per second. So 90 into 1000 divided by 3600, we get the value in meter per second, that is 25 meter per second. This is the velocity. Then surface temperature is given 85 degrees Celsius, that is TS is nothing but 85 degrees Celsius, and TA is nothing but 15 degrees Celsius. Ambient temperature or air temperature as a 15 degrees Celsius. Okay. So first of all, we have to calculate the mean temperature, because first of all, we don't know the values of the properties of the air. तर प्रॉपर्टीज ऑफ द एअर कुठल्या टेम्परेचरला बघायचं आहे, तर मीन फिल्म टेम्परेचर. तर मीन फिल्म टेम्परेचर कसं फाइंड आउट करतोय आपण, तर जे काय तुमच्या फ्लुइडचं टेम्परेचर आणि जे काय एम्बिएंट टेम्परेचर ह्या दोन्हीचं आपल्याला अवरेज घ्यायचं आहे. आणि त्या अवरेज टेम्परेचरला एक चार्ट असणार आहे. प्रॉपर्टी ऑफ एअरचा एक चार्ट आहे. त्याच्यामध्ये वेगवेगळ्या टेम्परेचरला एअरची डेन्सिटी काय असणार आहे, त्याची स्पेसिफिक हीट काय असणार आहे, त्याचा प्रँटल नंबर काय असणार आहे, त्याची विस्कॉसिटी काय असणार आहे, असा एक चार्ट आहे. तर त्या चार्ट मध्ये बघून आपल्याला ह्या प्रॉपर्टीज समजत असतात. ओके. तर एक्झामला आपल्याला हा चार्ट लागत असते प्रॉपर्टीज ऑफ एअरचा. तर त्याच्यामध्ये काय असणार आहेत, प्रॉपर्टीज ऑफ एअर असणार आहेत. म्हणजे 15 डिग्री सेल्सिअसला तर त्या एअरची डेन्सिटी किती असणार आहे, त्या एअरची विस्कॉसिटी किती असणार आहे, ह्या सगळ्या प्रॉपर्टीज त्या चार्ट मध्ये असणार आहेत. ओके. सो वी हॅव टू फाइंड आउट दी मीन फिल्म टेम्परेचर. ओके. सो TBM इज इक्वल टू 85 प्लस 15 डिवायडेड बाय 2 म्हणजे 50 डिग्री सेल्सिअस. तर त्या प्रॉपर्टी चार्ट मध्ये 50 डिग्री टेम्परेचरला एअरच्या प्रॉपर्टीज काय आहे ते फाइंड आउट करायचं आहे. ओके. सो प्रॉपर्टीज ऑफ एअर ऍट 50 डिग्री सेल्सिअस फ्रॉम टेबल. तो जो काही एअर प्रॉपर्टीचा टेबल आहे त्याच्यामधून आपल्याला ह्या प्रॉपर्टीज मिळणार आहेत. सो फ्रॉम दॅट वी राईट डाऊन दी प्रॉपर्टीज. TBM is equal to 85 plus 15 by 2, that is nothing but 50 degree Celsius. So properties of air at 50 degree Celsius from table असं लिहिलेलं आहे. तर ह्या व्हॅल्यू कुठून मिळालेल्या आहेत आपल्याला, तो प्रॉपर्टीज ऑफ एअरचा जो काही टेबल आहे त्याच्यामध्ये ह्या व्हॅल्यू असणार आहेत फ्रॉम टेबल. सो वी गेट दी व्हॅल्यू ऑफ के. राईट डाऊन के इज इक्वल टू 0.02824 वॅट पर मीटर डिग्री सेल्सिअस. K is equal to 0.02824 watt per meter degree Celsius. Then nu म्हणजे कायनेमॅटिक विस्कॉसिटी. कायनेमॅटिक विस्कॉसिटी इज इक्वल टू 17.95 into 10⁻⁻6 मीटर स्क्वेअर पर सेकंड. अँड प्रँटल नंबर इज इक्वल टू 0.698. ओके. सो ह्या प्रॉपर्टी ते आपल्याला त्या चार्ट वरून किंवा त्या टेबल मधून मिळणार आहेत. एअरचा जो काही टेबल आहे, वेगवेगळ्या टेम्परेचरला एअरच्या प्रॉपर्टीज काय असणार आहेत, हा असा एक टेबल असतोय. तर त्या टेबल मधून आपल्याला ह्या प्रॉपर्टीज मिळालेल्या आहेत. So from that Reynolds number, what is the equation for the Reynolds number? V into L divided by nu. So V is 25, L is 0.8 and nu is 17.95 into 10⁻⁻6. So from that we get the value of Reynolds number as a 1.114 into 10⁻⁶. आणि ही व्हॅल्यू 5 into 10⁻⁵ पेक्षा जास्त आहे. म्हणजे 5 × 10⁵ पेक्षा जास्त असेल रेनॉल्ड्स नंबर तर त्यावेळेला फ्लो कसा असणार आहे, टर्ब्युलंट असणार आहे. सो फ्लो इज टर्ब्युलंट. तर आपल्याला टर्ब्युलंटची जी काय रिलेशन आहे ती यूज करायचं आहे, त्याच्यावर आपल्याला हीट ट्रान्सफर कोएफिशियंट किंवा रेट ऑफ हीट ट्रान्सफर फाइंड आउट करायचं आहे. ओके, सो फॉर टर्ब्युलंट बाउंड्री लेअर as we know that Nusselt number is equal to h dash into L divided by K, and what is that equation? 0.036. Reynolds number raised to 0.8, Prandtl number raised to 0.333. So Nusselt number is equal to, use that relation, 0.0336. Reynolds number आपण find out केलेला आहे 1.114 into 10⁶ raised to 0.8. Prandtl number आपल्याला माहिती आहे 0.698 raised to 0.33. त्याच्यावरून आपल्याला Nusselt number मिळाला. Nusselt number is equal to, average Nusselt number is equal to 2196.92. ओके, आणि नसल नंबर्स म्हणजे काय असतं, एच एल बाय के, एच डॅश इंटू एल बाय के. सो एच डॅश इंटू एल बाय के इज इक्वल टू 2196.92. त्याच्यावरून आपल्याला एच डॅश मिळेल, एच डॅश इज इक्वल टू 2196.92 इंटू के डिवाइडेड बाय एल. सो बाय दी कॅल्क्युलेशन वी गेट द व्हॅल्यू ऑफ अवरेज हीट ट्रान्सफर कोएफिशियंट, दॅट इज एच डॅश इज इक्वल टू 77.55. ओके, आणि हीट ट्रान्सफर रेट कसा फाइंड आउट करणार आहे, क्यू इज इक्वल टू एच इंटू ए इंटू टी एस मायनस टी ए. एच आपण फाइंड आउट केलेला आहे. सरफेस एरिया आपण फाइंड आउट करू शकतो 0.8 इंटू 0.2, आणि टी एस मायनस टी ए दॅट इज 85 मायनस 15. वी गेट द व्हॅल्यू ऑफ क्यू दॅट इज 868.56 वॅट. 868.56 वॅट. समजले का बघा. तर एअरचा प्रॉपर्टीचा चार्ट आपल्याला इथं लागतोय. एक चार्ट असणार आहे किंवा टेबल असणार आहे, त्याच्यामध्ये प्रॉपर्टीज ऑफ एअर असणार आहेत, ते आपल्याला त्याच्यावरून मिळतील. मीन फिल्म टेम्परेचर म्हणजे हे सरफेस आणि एअरच्या अवरेज टेम्परेचर घ्यायचं आणि त्या अवरेज टेम्परेचरलाच प्रॉपर्टी बघायच्यात, लक्षात ठेवा. म्हणजे आता इथं किती दिलं आपल्याला, 85 आणि 15 आहे, तर 85ला किंवा 15ला बघून चालणार नाही. तर त्या दोन्हीचं अवरेज घेऊन म्हणजे 50, तर त्या 50 डिग्रीला आपल्याला प्रॉपर्टीज ऑफ एअर चेक करायच्या आहेत. ओके, so remaining part we have to take in the next lecture. Okay, so all of you put your roll numbers in the chat box.